Gravitation. This is our lecture. It is going to be lecture. In details, I will try to explain about it as far as I will have information regarding this. I will provide it to you. Here I wrote something about the gravitation. Now I want to start. I want to start this lecture. Name of this lecture is gravitation. Let's start meaning of gravitation. What do you think about gravitation? What do you think? Yes, it is a what? It is an invisible force. It is an invisible force. We cannot see this type of a force. This type of a force. When we say gravitation force, gravitation, gravitational force, then yes, it means we cannot see this type of a force. Here, something will fall. For example, this. I am leaving this marker. What will happen? This marker fall down. Why not upward? This marker fall down downward. Why not upward? Here it is a gravity. It is a gravitation because of gravity. Because of gravity of the earth. Here we cannot see what happened. Directly we cannot see what happened. But we can assume, we can observe. Here always remember, one object will attract to other object. Yes, it will happen. You can see. Here, when I was dropping this, when I was leaving this marker, then what was happening? This earth was attracting. Earth was attracting this marker, this object. Earth was what doing? What was Earth doing? Earth was attracting. It happens with all objects that objects are dropped from upward. Then Earth will attract that object. Yes. So here you can see Earth is attracting this mark. Only this will happen. Here always remember universal attractive force. It is what? It is a universal attractive force. I told you that it is a force. What? But this type of force we cannot see directly. We cannot see directly. We have to observe. We have to observe. If you wanted to see gravitation force, then you cannot see directly, but you can feel. Only you can feel. Universal attractive force. It is a universal attractive force that acts between any two objects, any objects, any two objects. This was one object, and my hand was other object. Earth is other object, and this marker is other object, another object. What is happening? This Earth, which is one object, and this other object. This is other object. Now Earth is attracting. This is not attracting. Earth is attracting. Who is attracting? Earth is attracting. And remember, only between them will be what? Attraction, not repulsion. We are not talking about magnetic effect. Okay. What if a question asked to you? Is it a magnet? Can we say that it is behaving as a magnet? It is acting as a magnet, too? No, we cannot say. We can say yes. One point is here from magnet concept. Only one, which is attractive. Okay. Only there will be only one object will attract to another object. One object. Universal attractive force that acts between any two objects. When I move here to here, then there are a lot of objects that are surrounding me. They are they are disturbed. They disturbed by me because I moved here, there. That's why all these objects disturbed. Okay. Yes. So always remember, two objects will attract, will attract. Yes, we can say that little attraction, amount of attraction is little, but still both objects will attract. Amount of attraction can be less, amount of attraction can be more, but amount of attraction will be something. Will be something. Universal law of gravitation. Here you can see I considered this one object and this is second object. We will take what distance from the middle of the one object to the middle of the another object. We will find distance. Okay, distance. As I told you, both will attract to each other. Not only one, but both will attract to each other. Here you can see. If both are attractive, it means both are pushing. No, both are pulling. Both are pulling. Attractive, which means both are pulling. Repulsion, which means both objects are pushing to each other. This is the meaning of repulsion. Attractive, which means both are pulling to each other. Pulling. Like that. Pushing. So I would say pushing. Okay, pushing. Both are pushing to each other. Yes. Like that. With the force of something Newton. Here force. If we say pulling, pushing, then it means we are saying force. Okay. Both are pushing. Both objects are pushing with some Newton. Okay. So here, this is what? This is a force, this is a force, and both force will be equal. Both force of both objects will be equal, always remember. And then what is the distance between them? Clear? We will consider one object as a m1, m1, m will indicate the mass of that object, and m again it is the indicating mass of another object. Here we will see what mass of the object will be important, will give you importance. Clear? From this understanding you will get formula to find force. Okay, formula, you will get formula inversely proportional to a square of the distance between two objects. I cannot say confidently that if both are near to each other, then I think force should be less. Okay, force should be less. But I should say that both are far away to each other, then force should be less. I think so. But no, it will not do. It will not do. Both are near, both are closely to each other, then we would say forces are less. If both are far away to each other, then we would say force are more. Force will be more. Yes. You can see, you can observe when we okay. One example I can give you, which will be which you can relate in a real life. When a person jumps from from height of you can say from one floor, you can say, from one floor. What will happen? From one floor, I am saying. When a person will jump from a floor of the building, then what will happen? That person can survive. Can survive. It means what? Both are attracted to each other with some force. With some force. Now, another case. This some person will jump from second floor of that building. Now what will happen? Something else will happen. Not same. Now that person can be that person can be that person can survive or not survive. Yes, because he jumped from from more height. If a person jump from a little height, then that person, then with that person will will not happen something. Nothing will happen with that person. If that person jumps from more height, then something will happen in that person. That person can survive, and that person can not survive. But if that person jumps jumps from more height, then it is a we can say that that person will not survive at all, because that person, when that person will jump from more height, then how can he survive? Yes. So what is happening here? What observation are you observing? Can I say you are observing that force was less when that person was jumping from less height? When he jumped from more height, then force was more force was more. So now here you can see, when both will be, so person and earth, both were closely to each other. That's why that person was able to survive. Now when he jumped from from more height, then both earth and person were far. That's why here force will be more. This force will be more. Yes, you can say. Now person cannot survive at all. Okay. Same here you can see, if both objects will be closely to each other, then force will be less. Newton will be less. When objects will be more, then you say that force newtons will be more. We will calculate Newton, don't worry. From this formula we will calculate. So here, inversely proportional to a square of the distance between two objects. Meaning of this is what? Can I say, if we increase distance, then force will increase, isn't it? This is meaning of this sentence. It is telling you, if we increase the distance of distance between two these objects, then force will increase. It is the meaning of a proportional, inversely proportional. If we decrease distance between these two objects, then what will happen? Force will decrease. Okay, force is increasing, distance will increase. Distance is decreasing, force will increase. Clear? Yes. It is happening in a real life. It happens in a real life. It will happen in a real life. Clear? Now, m is the mass for this object. m2 is the mass is for this object. Clear? Now it is saying you if which is a force. This hint is a inversely proportional. It is telling you if force will increase, then distance will increase. Meaning of this I am telling you, force will increase, then this distance will increase between these two objects. When force will decrease, then distance will decrease. Clear? This was meaning of this proportion. Now here, when we remove this, then we apply in place of this we apply equal to z. Okay, equal to z. Now here, what is happening here? F, as we know, F is a force, J is a gravity. Okay, oh, 1 second, 1 minute. Z is a universal gravitational constant. Always remember constant. When what is the constant? So always remember there would not be unit. Okay. 6.67 multiple 10 raised to power minus 11. 10 raised to power minus 11. Clear? Now here one thing more you will realize. What? Not now. This is the value of this z that we will put here. Clear? What is the mass? We will take what is the mass of this object and what is the mass of this object. Clear? And we will substitute a distance between these two masses. Clear? Then we will multiply by this universal gravitational constant. Value of this J is 6.67. Now here meaning of this is what? From this you can understand that it is a very weak force. Gravitation is a very weak force. You can simplify it. How? 6.67 it is telling. How much? Minus 11. So it is telling you 67. Okay. Can I say 10 raised to power 11? Yes. 10 raised to power 11. This is telling you have 11 zeros. How much? 11 zeros. Just take this and after counting this as a zero, count more that is left. For example, 3 and now we have 7. So 1, 2, 3, 4, 5, 6, 7. Now 6, 6, 7. 10.0. This is a Newton. This is what Newton. This is a force. And you can see how much Newton, how much force. Only 0.000. You will say that is it a force? 0.00. It is not even 1. Okay, this much force. This much. That's why it is said that gravitation force is the weakest force. Clear? 0.00 like that. We simplified in this form. It looks a bigger number, but when you simplify it, then you will get this number, which is very less. Why? Why very less? Because here you can see we have exponents in minus, in subtraction. That's why we have less number, very less number. Even not less than 0, not less than 0. You can say less than 1. Okay, so it is a very less number, but we realize sometimes that by looking at this we realize that it is a very greater number, but actually it is not a greater. Clear? Now here we as we know, mass is considered to measure in kg. This is also, we say this much kg. Mass of this object is this much kg, like that. And distance we measure in meter. Okay. Z as it because it is a constant. Clear? So it is telling you this should be equal to this. It means this is neutral, then this should be neutral. This is meaning of this, isn't it? We will understand it later. We will understand it later. Now, from this concept, try to understand. It is a attractive. It is a universal attractive force. Both objects will attract to each other. Okay, both objects will attract to each other. And now there are a lot of objects surrounding us. Uh, Two objects of them crowd objects are attracting to each other. Okay, with some neutral. Now here, always remember it is a attractive force, not a repulsive force. Now, what is if a distance between two objects are more, then force will be more. If a distance between two objects are less, then force will be less. Force will be less, and it also depends on what mass. We will talk it later. We will talk it later. Clear? Clear. Now, remember, it is a very weakest force. It is a universal attractive force. Okay, it is not a repulsion attractive force. Because both objects attract to each other. That's why. Formula will become F is equal to G, F is equal to G into M1 into M2 into upon R square. Here I wrote D square, but actually it will be R square. I wrote D so that you can understand, this is the distance between these two objects. We will write R. I will tell you about it later, about R. Now I am going to write next. Properties of a gravitational force. Okay, I am going to write properties of gravitational force. This is These are properties of gravitational force. as well as we will understand theory 4. Okay, theory 4. Here we will understand. After looking at this properties of gravitational force. What are properties of a gravitational force? Gravitational force has some properties that cannot be changed. First is it is always attractive in force. Okay, it is always attractive force in nature. In nature, it is a nature. What both will attract to each other with the same If one object if one object is attracting with 5 Newton, then second will also attract with 5 Newton. If a mass of both is the same, then okay, then now one point is clear that gravitational force will be always attractive force. Second is it is a very weakest force. We have understood in just in the backslide. This is the weakest force in nature, exists as a action reaction pair. Yes, if one object is applying force with the force of 5 Newton, so you can see other object which is in front of this is also applying how much 5 Newton. So both are same. So it is applying 5 Newton force. This is also applying. This is also is applying 5 Newton force. So it is what third. Newton's third law. It is a Newton's third. Always inverse law. This rule. Gravitational force will obey this rule. Force will increase, distance will increase. Force will decrease, then distance will decrease. Here, let's understand this. Okay. I told you why is gravitational force weakest because of it value of gravitational universal gravitational constant is how much 0.000063667. That's it. 0.00 is it a value? Okay, it is a value, but it is a very less value. Okay, even we cannot imagine. It is a very less value. That's why value is less. That's why we are saying it is the weakest force in nature. Now here Fury fall. Fury fall. Okay, Fury fall. What is a Fury fall? It is just saying that fall. Something is a falling. Is a Fury. Is a Fury. Something is a falling. Is a Fury. Object is falling freely. Nobody is stopping. Nobody is coming to stop the object that is falling. Here remember, if object is falling in under of gravity, then we would say yes that this is free fall. Object is falling, which is a free fall, because that object is falling in under of gravity. That's why. So there is no vacuum. For example, if you drop a ball, you will see what mass. If you drop a paper from a building, if you drop a paper from a building, from top of a building, then what will happen? Paper will come like that, like this. Paper will come, isn't it? So it is showing us. I can see you a paper. This is paper. When I will drop this, then what will happen? You can see. What is happening? This is falling like this. Okay. Why like this? Why is it falling like this? Because of particles are blocking this. Particles don't want. Particles are coming you can say this is coming, otherwise you can say this is hitting, this paper is hitting on particles. That's all. Particles is here, then of course particles will hit to this paper and this will be like this, isn't it? This is particles, so this is coming and particles, air particles, so like that particles will go. That's why it became like that, because particles went, particles passed like that. That's why it happens in air. Air has particles, a small teeny particles. That's why. And mass of this paper was very less. Mass of this paper was very less. Other, and one more point I would say, size. You can say volume. This was plain. This was plain. One more. Mass was very less. Okay. Okay. But this was plain. This was plain. If you will take this marker and I want to drop from height, then what will happen? This will come, this will fall direct. This will fall direct without any barrier. Why? Because mass of this is more than mass of particles. That's all. Particles are not able, air particles are not able to stop otherwise to hit to this object, because mass of particles are less. That's all. That's all. So here something, and it is falling in under of gravity, That's why we can say this is a free fall. This object is a free fall. Okay. Okay. Clear? Paper is a free fall. Moon, which is rotating around the earth, is a what? Free fall. You would say, then why is the moon not falling? Yes, it is not falling, but it is said that moon is a free fall. Okay. I know moon is not falling, but it is said that moon is a free fall. Now, if there is a vacuum in air, vacuum empty, we take a area and there is nothing, and we drop from here, we'll drop something. Then here, this is area. We want to drop a paper from here and from here. What will happen? Here, in this area, there are particles. In this area, there are not particles at all. Okay. Here, this area is very empty. But in this area, there are particles, small particles. What will happen? This paper will come like that. Isn't it? And it will fall. And here, paper will come directly, and then it will sit here. In this, paper will come direct to the earth, because there was not air particles. That's all. Air particles were not. There were not air particles. That's why nobody know, like nothing are stopping this paper. That's all. Here particles are trying to stop this paper. Why? Because here there are particles. That's why. But in this area there are not particles. That's why paper came directly on the earth. Clear? Now next concept. Now next, acceleration. Acceleration. Here, acceleration due to gravity. What is happening here? What is happening here? Acceleration due to gravity. Acceleration due to gravity. We will find what acceleration of gravity. Here you can see here apple is falling on the earth. Apple is falling on the earth because of both are attracting to each other. Both are attracting to each other. That's why apple is falling on earth, on surface of earth. Now here, when we will drop this apple from a certain height, then a speed of here, a speed of this apple initially was what? Zero. Now as we drop this, then acceleration, a speed of this apple will increase gradually, not immediately, gradually, like that, like that. So what is happening? Initially a speed was something here, and between a speed of this was something else, and final speed was something else. So it is what? Acceleration. It happens in a real life. It is a nature. When we drop something from a height, from a far height, then a speed of that, uh, a speed of that from top will be less. But as that object will come to the near of the other object, then a speed of this object will increase gradually. That's why it is what? Acceleration. Here we see what? A speed increased. A speed will increase. You can see apple is coming now. A speed of this apple increased. Now here we see two forces. Here this earth is also forcing, this earth is also forcing, and this apple is ours, this apple is also pushing. As we saw that this earth will be pushing and this apple will be pushing, both are pushing to each other. And what will happen after falling? This apple will be here, where apple will be here with the surface of earth. What is happening here? What is happening here? This is earth, okay? This is earth. Here, I am standing here. Now, earth is pushing me, and I am pushing the earth. It is a force. It is a force. Both are pushing to each other. I am pushing the earth, and earth is pushing to me. Okay, it is happening. It is happening regularly. Now here you can see this one force. Force of earth is pushing this, and a force of this apple is pushing this earth. This is what is happening here. This is what is happening here. Clear? Now here net force is a 0. Net force is a 0. Clear? Now what we understood acceleration due to gravity. Now what is this? What is this formula? We don't have we don't have m1 into m2, not at all. We don't have m1 into m2. Instead we have m into m. Why mass of this earth is greater and mass of this apple is less? That's why I wrote m in capital letter and second m in a small letter, because mass of this earth is more. Mass of this earth is more, and mass of this is less. Okay, that's why. Now distance, you can say distance. R is a distance. R is a distance. Here R is radius. So radius of this from here to here would be radius, and radius from center of the apple to the outline of the apple. This is radius. That's why it is written here. Now both are radius. But what about this gap? And that's why we apply this a square. This a square. Okay. We have written R, but what about a square? Now here we wanted to find isolation. Okay, we wanted to find isolation of apple. Isolation of apple. And then we will find isolation of earth. These are formula. To find out isolation, as we know, we know that F is equal to m, where m is a mass and a is a isolation. F is a force. We know. Okay, what else? To find out isolation, we can say m upon f, isn't it? Not this f upon f. To find out it. To find out m, we can say a upon f, isn't it? We wanted to know isolation of this apple, then we will apply this formula. Clear? Now next, what do you think about centripetal force? Centripetal force. This is a circle. Here is one object. Here is another object. We have two objects. Now try to understand this. Try to understand this. Here we have two objects. One is at center, second is rotating around this object. What is happening? Why this is rotating around this object? Because of it is a centripetal force. Here this is acceleration. This is acceleration. Okay. This is acceleration. And here this is a direction. This is a direction. Here acceleration is a directing this. Acceleration is telling that you have to rotate like that. Who is acceleration? Okay, this distance. So a force that acts on a body moving in a circular path. Moving on a circular path. You can take a needle, a thread, and a stone, and you can do like that. What will happen? Stone will move in circular path. Why? Because thread is a built up with this stone, and this thread is giving instruction that you should move in circular path. That's why. Okay, directed towards the center of the path. It is also a force, but it is a centripetal force. Why? Because it will rotate. Okay. Centripetal is a force which rotates around a object, and the distance between them will be acceleration. That acceleration will decide that you have to move around. You have to move in circular. Now my question is, what is mass and what is weight? Mass and weight. WEIGHT. What is a mass and what is a weight? Let's remember, mass will tell you quantity. Quantity. Okay. How much kg is this? How much kg What is the mass of this? You would say 2 kg. What is the mass of this? You would say 3 kg. Okay, like that. So here you are telling what quantity. But in this, you would say it will depend on acceleration due to gravity. What is the meaning? What is meaning? Force. What is the word? Force. You say that I am applying this much force, this much force. Force of attraction. Force of attraction. Here, when a object is dropped from a height, then what happens? Mass of that object you can observe. So mass of that object is falling in in particular distance, in particular direction. That's why here you will get direction. Okay. With how much force? With how much force? So weight will depend on force. Weight will depend on force. Mass will not depend on force. Okay. It will tell you quantity. Clear? And this weight you can observe with the example of previous example. Here force of attraction. Weight. Okay. Weight. Something else. For now, till here. Now, one question I would like to ask you. One question. This question exists in real life. This is a question. This is question. Question is saying why can a man jump higher on the moon than on the earth? Higher jump, higher on the, okay, higher, yes, higher. When you jump like that, okay, then you see you can jump more. You will be able to jump more on moon, not on earth. Only you will do like that, then you will jump a space between you and moon will be more when you will jump on moon. Then why it happens? Why does it happen? Answer is because of less gravity. On moon, on surface of moon is a very less gravity. On earth is a very high gravity. Amount of gravity on earth is more. Amount of gravity on where? Amount of gravity on more than moon. Than moon. What is the meaning of this sentence? It is telling you here moon will attract very less, but earth will attract more. Gravity on earth will be more. As you go to near, as you go to near of the earth, then you will apply not more. Okay, leave it. Amount of gravity on earth is more than moon. It is the answer of this question. Clear? It happens. It is the nature. It is the nature. What is a thrust? What is a thrust? What would you like to say about it? It is also force, but force of this will be perpendicular. We apply like that force, perpendicular. Okay, perpendicular. It is a force on perpendicular. Force perpendicular to surface. We apply force but perpendicular, not like that. This is not perpendicular. This can be perpendicular, but I am talking about like that. Okay, I am talking about like that. Perpendicular this, not this. Okay, so it is also force, but we apply force perpendicular in a way of perpendicular. Clear? This is 1.4 defining thrust. Now remember, I am saying it is a force. So can I say that SI unit of this would be SI unit of this would be what? Same Newton, because it is a force. What difference? What's the difference between force and Newton? Force and the thrust. It is also force, but we will apply force like that. Now we are applying like that force. It means thrust. Okay, pressure, thrust. Okay, yeah. Which quantity is it? You would say, if this is a force, so you can say this is vector quantity, because reason is it is a force. That's why it is a force. That's why. Clear? Now next, opposite pressure. Here, this is a thrust, this is a pressure. Always remember, pressure would be a scalar quantity. What would be formula to calculate a thrust? Just write a thrust and area multiple pressure. Area multiple pressure. This is a way of calculating thrust. We will multiple area by pressure. Clear? Now, always remember, pressure would give you only magnitude, not direction. But here, thrust, we are applying thrust force. So here you are you can see this is the direction, this is the direction, but pressure is not a direction, right? Area. Okay. That's it. Now something else. Now what is a Beyonce? What is a Beyonce? What is a Beyonce? Beyonce. Meaning of this is very simple. It is also force. But which type of force? Here we can take a tab in which there will be some water. Some water. Okay. We can take a bigger otherwise tab. Now you dropped a you can say break like that. What will happen? What will happen? Here this water is applying what? This water is stopping. This water is stopping this break. So can you say if it is stopping, it means it is pushing, not pulling. This is pushing. Now brake is also pushing this water. Yeah. Is it happening or not? Yes, happening. Brake is pushing the water and water is pushing the what? Brake. This is that. This is what is happening. So a force which is upward. A force is a what? Upward force. This is upward force and this is a downward force. So upward force, upward thrust, you can say upward thrust, because it is a perpendicular. So upward thrust is what? Beyonce. Upward thrust is a Beyonce. Clear? So always remember, upward thrust will be Beyonce. Beyonce. What is a Beyonce? It is a up thrust. It is what? It is a up thrust. Now something else. You can say this is up thrust because of it is a perpendicular force. That's why. Now something else. If one point more, if mass of this object which is in water, if mass of this object would be more, then this will sink. This will sink in water because of mass of this object is more, and mass of water would be less. Volume of water would be less and mass of object would be more, then of course this object will sink. If mass is very less, let's say this is a bottle, now it will not sink, it will float like that. Why? Because of mass is very less. If mass is normal, not less, not high, then it will be between of the water. Clear? So answer of question is what? when would a object sink? When would a object not sink? Then answer is what? It will depend on mass. If mass is greater, a mass of an object is greater, then that object will sink. If mass of that object is very less, then that object will float. If mass of that object is very normal, then we can say that object will be center of the water. And volume also here volume also matters. Okay, but one point is very clear, that here you will realize mass. Here mass clear. Now next is next is read this question. Now here you will understand volume. Read this question and answer this question. Why egg floats? Why egg floats in salty water? In salty water. Now here, as you can see, in this glass, egg is not floating. In this glass, egg is not floating. But in this glass, egg is floating. Why like that? Why is it happening? Because consider mass of this object, mass of this egg would be something. If it is not flowing, it means it is sinking, it is sunk. So can we say mass would be less, mass of this egg would be very less? That's why, very less. Okay, that's all. Now here, mass is the same as compared to this. Mass of this egg is the same, but here this is a salty water. This is what? This is salty water. Remember, this is salty water. What is happening? Here volume. Now mass of this, otherwise you can say volume. I would say mass of this water is how much? More. Is how much? More. Very more. Okay. That's why this egg is floating. That's all. But here water was not salty, and mass of this was less as compared to mass of this water, which is in glass. I will tell you complete answer of this in separate lecture.